Differentiation. Now in calculus, differentiation and integration are very important concepts. Most of the time we have certain relationships, we know the formulas, so we do the differentiation. But what exactly is differentiation? Why we do it? In physics, you might have heard about rate of change. Differentiation is nothing but rate of change. I'll prove it. For example, if you take your car, you are running, you are walking. How to differentiate? How to find the differentiation? Let us understand by this example. Now this is a car. Now this car goes for 40 meters in 5 seconds. So this is a fixed time, fixed distance. So the gradient or the rate of change of this scenario, it tells us what? The rate at which the distance changes with respect to time. As the time progresses, the distance changes. So distance is changing with respect to time, and that is called the speed, and that is called the gradient here. So slope, m, tan theta, dy by dx, all are rate of change. Rate of change of distance with respect to time, rate of change of x with respect to y. So this graph or this example, in order to find out the gradient, what we will do? We will find out at what time or in what time duration what distance has been covered. We'll take a ratio and the speed will be found. That is, gradient here is the speed. Gradient tells us the speed of the car, which is nothing but the ratio of two values which are changing with respect to one another. So gradient is not distance upon time here. It is change in distance with respect to the change in time. So how the time changes, and with the time how the distance changes. For example, we have t1, t2 as the time duration. d1, d2 is the distance travel in this time. So at t1 the distance was d1, at t2 the distance was d2. So the distance change d2 minus d1, the time change is t2 minus t1. So the time change is related to the distance change, and the distance change is related to the time change. But here it's 40 divided by 5, because here we have taken t1 and d1 as 0. The time is 0, the distance is 0. So 40 minus 0 and 5 minus 0. So you have a very, you can say default answer or a regular answer, a regular gradient, regular speed, that is 8. So in physics, just add physics here, meter per second. So now the question is that this is a constant speed. This car is an example of constant speed, because the gradient or the slope or the m or tan theta is same everywhere for this graph. It is not changing. Here we are not concerned about differentiation. But if somebody asks you that in a real scenario, because in real scenario, the car will start from 0, it will attain certain speed, it will slow down, it will accelerate, and then it will come to a stop. So in most of the situation, the speed will not remain constant. I'm not showing this, picture just to show that the speed is not constant, never be constant. The distance time graph will not be a straight line, it will be a curved line, right? Because you start from the rest, you have traffic stops, you have people, you have maybe animals. So the speed of the car, which is what we're calling as the gradient or the slope or the ratio of two value, changes as you move along the curve, or the speed of the car changes when you from destination point A to point B, that is the source to the destination, you move. Okay? So somebody asks you, tell me the time or tell me the distance at say 3 seconds, 3.2 seconds, 3.1 seconds. I'll give you one more example. For example, you are earning something. With respect to age, how is your income changing? So the rate of change of income with respect to the age is differentiation, is gradient, is slope, is m, is tan theta. That is the instantaneous value. The process of finding the rate at which one variable changes with respect to another is called differentiation. Okay, so this is all about income changing with respect to age, the distance with respect to time. So in most of the situation, we are finding the gradient or the slope of a curve. Not, it may be a straight line also, but mostly the curve, and that is the rate of change of one value with respect to another is your differentiation. I hope you got the idea of differentiation. The gradient of the tangent at a point. Whenever we are talking about differentiation in mathematics, we are talking about the slope, the angle, the gradient of the tangent at certain point of the curve. If you take any function, that particular point where you want to find out how the value of x change with respect to y, you are finding out the slope, you are finding out the m, you are finding out the tan theta, you are finding out the gradient, you are finding out the dy by dx. So you are going to draw a tangent at that point. We have always heard about circle. There is a point where a line touches, that is called the tangent, and the line which is perpendicular to this tangent is called the normal. So that particular point where it touches that line, the slope or the angle it makes with the x-axis is the gradient or the slope. So the gradient of a curve at a point is given by the gradient of the tangent at that point. Because how to find out the gradient? We can find out the gradient by finding out the angle or the gradient of the tangent at that point. So you are interested, whenever you are going for differentiation, you are interested in finding out the slope of the tangent. So if you have a straight line, what do? Normally, go back to your basics. You have 2 points, you have a straight line, so easily you can find out the gradient or the slope. If you have a straight line, you can easily find out. But what about the curve? For that we have to do something different, extra. So if you have a line, you have point x1, y1, you have point say x2, y2, and it's very easy to find out the gradient or the slope, that is the angle it makes with the x-axis. Positive angle. Okay, so the distance traveled at x-axis is x2 minus x1. The distance covered in the y-axis is y2 minus y1. So what is the angle? It is tan theta. Tan theta is simply perpendicular by base. What is perpendicular here? What is base here? Perpendicular is the y-axis here. If you make a triangle here, it will be y2 minus y1, and the base is x2 minus x1. This is a simple explanation for the slope, that is the change in y divided by change in x. So how y is changing with respect to x is computed by y2 minus y1 by x2 minus x1. The gradient of the tangent has a limit. So we cannot just stop by finding out the gradient when we are doing differentiation, because the gradient is all about the tangent. So if you have a straight line, then y2 minus y1 by x2 minus x1 if you take 2 points. But what about the curve? In order to find out the differentiation, you have to find out the tangent first, and tangent tan theta, that is the y2 minus y1 by x2 minus x1 of the tangent. How to find that? Tangent touches only at one point, remember. So we cannot have a 2 point. For that we have to do what? We have to find say the tangent or the differentiation at point A. So we will try to find out another point B which is very close to it. So we have a A point, we have a B point. So in order to make a straight line, we need 2 points. So by these 2 points, we can make a line. But what we'll do, we'll try to merge A and B. We will try to bring A and B so close that they will become 1 point. Now we are getting the tangent. So making a tangent on this A and B which are coinciding, that can solve our purpose of finding out the slope, for finding out the y2 minus y1, finding out the differentiation. I hope you got the idea. This is a chord, this is not a tangent, but in order to find out the gradient of a curve, we need a tangent. For that tangent, we take 2 points, try to merge them. So that small difference where B will be there from A is called del X. We'll call it as del X or del Y. Very small change. It is equal to 0, not 0, it is equal to 0. Okay. That will give you the instantaneous value of the rate of change of one value with respect to another on that point. That is the tangent. So what we'll do is, we'll move A and B closer, 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 closer until they become 1. Once they become 1, we can find out the gradient. So the gradient of the chord is simply change in y by change in x. So it will be any straight line. But now the A and B are so close, very close, that the distance between them, these 2 points are very small. Del x, del y. Del x and del y. So del x is simply y2 minus y1, x2 minus x1. But we can call y2 minus y1 as delta y because the distance is very small. It is equivalent to 0. Now this is 0. I am saying that this is equivalent to 0, not 0. So A and B has coincided. So A and B are coincided. Now you will say, oh, delta y will be 0, delta x will be 0. It will be a form of 0 by 0. That is not acceptable to us. It is undefined. What to do then? For that we need limit. That is why we need limit in differentiation. So the del x tends to 0. When we want to find out the value of y changing with x, we will take that del x tends to 0. It will not be 0. Otherwise, we'll get a value of 0 by 0 or something by 0, which is incomprehensible. So del x is so small. It is so infinitesimal. It is not equal to 0, but it is almost 0. Differentiation from first principle of y equals x square. So all the differentiation result can be found out using the first principle. We'll take an example of y equals x square. Now the differentiation of y equals x square is 2x. This is 2x. From where it has come? How did we get this 2x? Now the same concept we'll do. In order to find out the differentiation, we have to find out the tangent on that point of the curve. So y equals x square. So if x is x, then y will be x square, because y is x square. So x1, y1 we are not writing. We are writing x as x, and y is, because y is equal to x square, so y will be x square. Now we are saying that we will try to have a point B which is very close to A, and finally we'll try to make A and B together, that is coinciding one another. Because we want tangent. Remember, we don't want a chord. So we are just adding a small value, x plus delta x. We are just, when we take x plus delta x, the y will be y is equal to x square. So it will be x plus delta x whole square. Okay. So one is x, the other is x square. When you add x plus delta x, the other value will be x plus delta x whole square, because y is equal to x square, which we are finding. Now first let us find out the gradient of the chord. Because 2 points are there, it is easy. y2 minus y1, x2 minus x1. This is the gradient of the chord. Remember, we are not interested in the chord. We are interested in the tangent. So y2 minus y1 by x2 minus x1. What is this? X plus delta x whole square minus x square divided by x plus delta x minus x. This is a plus b whole square, a square plus b square plus 2ab minus x square divided by whatever is this. It means x2 minus x1. Just cancel these two xx. Okay. So y2 minus y1 we have taken in the numerator, denominator we have taken x2 minus x1. I hope you got the idea. So del x del y is very, very small. We'll make it smaller by putting del x as tending to 0, limit. Now cancel this x square, the denominator also xx will get cancelled. Del x you can take common from the numerator, del x plus 2x will be inside, del x you can cancel. Del x plus 2x will remain. But what did I tell you? We are not interested in these 2 points. We are trying to find out the 2 points together. We want a tangent. So ultimately A and B has to be together. For that, what we have to do, this delta x, that added point where B lies, we are tending it to be 0. We are saying it is so small, delta x is 0. We are assuming it to be 0. But we cannot put as 0, otherwise we will get 0 by 0 form or something by 0 form. So when del x is 0, put it here, 2x plus del x. Del x 0, it will be 2x. Okay, so del x by del y by del x you cannot just write. You have to write del y by del x limit del x tends to 0. Okay, so we took 2 point. We try to find out a chord and then we make it as a tangent. So y equals x square. This is how we got y is equal to x square. The differentiation is 2x. This 2x is called as a gradient function, and it is also called as a derived function of y equals x square, or simply you call it as the differential or differentiation. If you are using, say, function y equals fx, this fx can be log x, it can be a to the power x, it can be any function in mathematics. So the differentiation is f dash x, or the gradient or the slope or m or dy by dx is f dash x. So x square is fx, f dash x will be 2x. So I'll just give you an example. You have a function y equals x square or fx equals x square. Now you need to find out the gradient at the point 5, 25. That is a point on the curve. How to find out? F dash x is what? 2x. Take the value of x, put it here. So 2 into 5 is going to be 10. This is your answer. This is your differentiation. Now if we have a point, we are just extending it to be more clear. If we have a point 3, 9 on this curve, y equals x square. Now B is a point very close to A. So we just add a delta x, very small. It can be assumed to be 0. So 3 we are adding just a delta x. And what will be the y? Because x is 3. So y will be what? 3 plus del x whole square. Because the function is y equals x square. So we will find out the gradient or the slope of the chord from A and B. There is a line. So y2 minus y1 by x2 minus x1 will be line. So del y by del x. Why we are writing del y del x? Because the distance we have assumed it to be very small. They are almost A and B are together. Okay. Because we want an instantaneous value, and that can be only found out using the tangent. So we have y2 minus y1 by x2 minus x1. That is this value which I just told you. So now a plus b whole square, you can open it using a square plus b square plus 2ab. And numerator 9 gets cancelled. Denominator 3 gets cancelled. You can take a del x common from here. You just cancel it. 6 plus del x. So del x, finally you have to write 0. Del x limit tends to 0. Why? Because a and b are not different. They are one over another. They are one. Okay. That is how we find out the slope of, or the tan theta or the dy by dx of that tangent which is passing through that particular point where we want it. 3 and 9. So the differentiation or the del y by del x limit del x tends to 0 is going to be 6. Remember, del y by del x limit del x tends to 0 is simply dy by dx. This is dy by dx. So this is how we get the answer. I showed you using x and y, and now I showed you with an example. So this is how the first principle works. This is how the differential works. Y equals x cube. Now this is also a polynomial called as a cubic function. So how do we differentiate it? And what is the first principle? How do we apply on it? So y equals x cube. I am just making a random curve. So in order to find out the differentiation, we have to find out the slope or the gradient of the tangent. But we have to take 2 points. The first point is x1, y1. So if x is x, y will be x cube. And since 1 point tangent difficult to get, so we formulate or we try to find out another point b. And finally, when we solve everything, we combine a and b, that is a on b. So we are just adding a little bit because we want to find out the slope, that is only instantaneous value of x changing with y. So x plus delta x, and then the y point will be x plus delta x whole cube. So what we will do is delta x tends to 0, then a and b will coincide. 2 points we have taken to find out the slope, to find out the gradient of that line. But we have to make it as 1 because the tangent at that point will give you the differentiation. will give you the gradient, will give you the slope, right? So the gradient of the chord, please remember the chord, that is the line touching 2 points of the curve. So y2 minus y1 by x2 minus x1, this is the gradient, this is the tan theta, this is the slope. Okay? Now what we'll do is, y2 we know, these are the values. So x plus delta x and by x cube minus y, y2 minus y1 by x2 minus x1, that we will do. Okay? Simple. So this x gets cancelled, and finally we have a plus b whole cube formula. So a cube plus b cube plus 3ab, a plus b. So when you apply this formula, a plus b whole cube, x cubes get cancelled, and delta x you can take common. When you take delta x common, you have delta x in the denominator, it gets cancelled. So this delta x wherever it is, finally we will apply the limit. Why we are applying the limit delta x tends to 0? Because we have to coincide a and b point, we want the tangent. So that a and b distance should be at least, if not 0, equivalent to 0. Right? So this is to go into your mind. We want tangent, not the chord. So we are making the chord and ultimately making it as a tangent. By del y by del x tends to 0. This comes as 3x square, because all other term when del x equals 0 becomes 0. So y equals x cube. The differentiation of this y equals x cube is nothing but 3x square. So this limit x tends to 0, delta x tends to 0, del y by del x is nothing but dy by dx. Okay? This is 3x square by first principle, the differentiation. So the gradient of this tangent of y equals x cube we just found out at any general point. You can take any point on the curve and you can tell this is the instantaneous value of this curve at this point. So dy by dx is x cube is 3x square. So fx, the function was x cube. Now there are various ways to represent it. That is f dash x is the gradient of the tangent, and that is going to be 3x square. And this is also the differentiation. The differentiation is represented by f dash x. So in order to find out the gradient of the tangent of curve this y equals x cube, say at point minus 2 minus 8, f dash x we already found out, this is going to be dy by dx also, that is going to be 3x square. You just have to take this minus 2 value, put it here, and then 3 into minus 2 whole square is 4, it is 12. So f dash x is 3x square. At the point minus 2 and minus 8 or negative 2, negative 8, you get f dash minus 2 as 12. Now you have to give me the answer why the gradient of fx equals x cube is always positive. Now this dy by dx notation is the differentiation notation. That is the rate of change of y with respect to x. Now this has come from del y by del x when we put limit del x tends to 0. This has come from this point. Now we have a curve. We want the tangent and the gradient or the slope of the tangent positive x-axis. That is your dy by dx. So what we do is we take 2 points a and b, and these 2 points are differentiated by del x. Then we combine this a and b point and make del x equals 0 or tends to 0. So del y by del x, when limit del x tends to 0, when a and b points coincide, so you get a tangent on that curve, and that is usually written or denoted by dy by dx. So that is what dy by dx stands for, right? So if you have y equals x cube, the dy by dx is 3x square. This is nothing but limit del x tends to 0, del y by del x. Dy by dx, it is representing the derivative of y with respect to x. Now if you write ds by dt, the change of s with respect to t is your derivative. It is not always dy by dx. It can be any two values, one value changing with respect to another. That is called the derivative or differentiation. Please remember, del y by del x is the gradient of the chord, a line touching the curve in 2 points or cutting the curve in 2 points. But dy by dx is the gradient of the tangent, that is the tangent is touching only 1 point. So we take 2 points, try to find out the slope of the line, and finally we can coincide a and b, that is the tangent, and tangent slope is your dy by dx. that is going to be your differentiation, that is going to be your derivative, that is going to be your f dash x, that is going to be y equals x cube 3x square. Differentiation of polynomials. Now when we'll do differentiation, the polynomial will be the default questions. You know, you always have an x, always. So x will have multiple powers, negative power, positive power. So x is a variable. If you put 2x, 2 has no meaning in differentiation because 2 is a constant. X is a variable. So the differentiation will be done on x. So x differentiation is 1, x squared 2x, x cube 3x square, x4 4x cube, xy 5x raised to the power 4, x raised to 6, 6x raised to the power 5. Now you see a pattern, and this pattern has come from the first principle, and that first principle says when you have y equals x raised to n, the differentiation, the derivative of dy by dx is n, x raised to the power n minus 1, n multiplied by x raised to the power n minus 1. This is your differentiation of a polynomial. Now, as I said, there you will encounter various multipliers, and if they are constant, you don't have to worry about it. Dy by dx is always with respect to certain value. Here it is with respect to x. So you have to differentiate x. If you are not differentiating with respect to x, x will be treated as constant. You will learn that in the differential equations. So dy by dx, a raised x minus 1, a raised x to the power n, leave the a. For example, you have a y equals 2x to the power 4. So as I said, a is 2, constant is 2. You don't have to worry about 2, just keep 2. X raised n differentiation is nx raised to the power n minus 1. So here we have 4x raised to the power 4 minus 1, and that is going to be 8x raised to the power 3, and that is going to be the differentiation of this polynomial 2 into x raised to the power 4. Now there is a very peculiar case, constant value. For example, y equals 2, y equals c, y equals minus 5. Now if you go to the coordinate geometry, or you can say the Cartesian coordinate system, you will see that y equals c means a line which is parallel to the x-axis. You have a value c, which is y. So the distance of that line from the x-axis is c, constant. But it is parallel to x-axis, so there will be no angle. The angle of that line with the x-axis is 0. So the tan theta will be 0, dy by dx will be 0, m will be 0, slope will be 0, gradient of that line will be 0. So the gradient of this line, constant line, will always be 0. So differentiation of a constant value will be 0. So y equals to dy by dx of this constant value is 0. So you can assume that 2 into x multiplied by 0, x raised to the 0, x raised to 0 is always 1. Okay, anything to the power 0 is 1. So 0, x raised to power 0 minus 1, so you have a 0 here. That is how you can understand how this 0 comes. So y equals c, or any constant value, dy by dx is 0. Now we have the point. So there is a curve. There is a point minus 2 and 48. So you have to find out the gradient of the curve y equals 3x raised to the power 4. So essentially the question is asking find out the derivative of this value at minus 248. So in order to find out dy by dx, 3 is a constant. You don't have to worry about that. X raised to the power 4. 4 comes front. X raised to the power 4 minus 1. 3 into 4 is 12. X raised to the power 3. This is 12, x raised to the power 3 is the gradient, is the differentiation, is the derivative of 3x raised to the power 4. Now you have to choose the point minus 2 and 48. Just put minus 2 in place of x. What do you get? 12 into 2 into 2 into 2? Negative 2, because it is negative to the power 3. You get minus 8 into 12. That is going to be minus 96. Negative 96. This is how we find out the differentiation. Now we will not get these simple polynomial functions. We will get the combination of different terms in a polynomial function. For example, y equals x to the power 4, nx to the power n minus 1, 4 in front, x to the power 4 minus 1, that is 4 into x to the power 3. But here we have multiple terms, x raised to the power 4, 3x square, negative 5x plus 2. So in order to differentiate the whole polynomial, we can take different terms one by one, differentiate them and then combine them together. For example, x to the power 4 differentiation is 4x to the power 3. You have to follow x raised to the power n minus 1 every time. Okay, 4x to the power 4 minus 1 is 4x to the power 3. What is 3x square? 3, don't worry about that. X square is 2x, so it becomes 6x. 2x raised to the power 2 minus 1 is 2x. 2x into 3 is 6x. Minus 5x, again x raised to the power 1 it is. So x raised to the power 1 is what? 1x to the power 1 minus 1. So you get minus 5 into 1, x raised to the power 0. Anything to the power 0 is 1. So you get negative 5 only. So the differentiation of x is 1. Please remember. And differentiation of a constant is 0. Right? So when you have the polynomial made up of sum or difference of a number of terms, the derivative will be made up of the derivative of each of the polynomial function, or you can say each of the term in the polynomial function. So if you have fx and gx, assume it to be two terms, x raised 4 and 3x square, fx gx. Just do the differentiation and combine them with respect to the sign. Sometimes, in some cases, there are different ways to do it. Okay, if you have this function, for example, 2x minus 3 and x raised to the power 2 minus 5. Now, the best way is to do what? Multiply it and solve it. But there is another way. If you assume one to be gx, the other to be px, what you can do is, you can do the differentiation of the first one, keep the second one like that, plus differentiation of the second function and first one like that, no change. So f dash x plus gx plus fx plus into g dash x, or in this case, first function differentiation, second function don't change, plus second function differentiation, first function don't change, add them. But the better way here is to multiply these two terms. When you multiply these two terms, you get different terms, and these terms can be differentiated individually and they can be combined in this way. So in order to find out the gradient of this function at the point negative 3, negative 36, you already have a f dash x. Just replace negative 3 in place of x and you are going to get the result like this. So f dash x is gradient, f dash x is the differentiation, f dash x the derivative, which is 62 here in case of minus 3. Most of the time, there will be different kind of polynomial being presented to you. For example, you can have px by gx, qx by px, px by tx like form. Means numerator and denominator you will get. Right? So first we will do what? 3x raised to the power 5, 2x denominator, keep it below every term in the numerator and then solve it. This is a good way. But if you have an easy solution, what if you have polynomials, complicated polynomials? This is a simple differentiation. You already know it. N x to the power n minus 1 for x to the power n. Differentiation is like this. But you have a constant, leave it. So the other way of doing this is to differentiate the numerator multiplied by the denominator, subtraction of the denominator differentiation, multiplication of the numerator like that. So numerator, denominator you have to differentiate. Keep it like this. Numerator, denominator, numerator, just keep it like that. And then you subtract them and the denominator gx whole square you have to divide. So this is how you differentiate the polynomials of px by qx form or numerator denominator. What is second order derivative? Now derivative is simply slope or gradient. So the second order derivative is the differentiation of differentiation. What does it mean? Y is equal to fx, dy by dx is what? F dash x. Differentiation of function. But when you do again the differentiation of the differentiation, that is d2y by dx2, that is how we represent it. It is f double dash x. So you are differentiating the value or the function twice. But dy by dx is the gradient or the slope of the function at one point, which is the tangent. But f double dash x is the sign whether the function is increasing or decreasing, whether the function is concave, upward or downward. That is what second order derivative represent. So we always find out the second order derivative and then find out the sign. The sign will tell you whether it is increasing or decreasing. So dy by dx is the gradient, is the slope, and the gradient of the gradient, that is the slope of the slope, is the second order derivative. So second order derivative, it provides us the rate of change of the gradient of the function. That is how the slope of the tangent, the angle of the tangent is changing with respect to the forwardness. So we can think gradient of a gradient is second order derivative. Dy by dx is m, slope. d2y by dx2 is the slope of the slope. So if you see the diagram here, it represents why we actually use second order derivative. What does it gives us? So we have say a graph can be like this. A graph can be like this also. The graph can be like this. There are different kind of graph that we encounter. So the second derivative of a given function, that is the slope of the slope, gradient of the gradient, it tells us it corresponds to the curvature or the concavity of the graph. How concave it is. How much, that is in the simple term, if the second order derivative value is positive, then the graph of a function is upwardly concave, it is increasing function. Okay, it can be negative, it can be positive, but the second derivative is found specially to find out the curvature or concavity. Cavity, that is second order is positive, graph is upwardly concave, second derivative negative, it is downwards. Tangents and normals. Now this tangent is nothing but a line touching at one point on the curve. So we have always learned this with respect to the circle. A circle, there can be any curve. Okay, why we are talking about circle? Because it is easier to understand. So this tangent, when you have a 90-degree line crossing that tangent, that is called the normal. So this is a tangent touching one point. If you connect this point where the tangent is touching with the center of the circle, that is going to be the normal, and that will be 90 degree to the tangent. Okay, so tangent to a curve is a straight line that touches only at one point to any curve, and normal to this curve at that point is a straight line that is actually perpendicular to the tangent. So we may use a differentiation in order to find out the equation of the tangent and also the normal to the curve. Let us take an example. So we have a function called y equals x square minus 5x plus 8, and the point is 3 and 2. It can be any curve. A polynomial can have any form of curve. You need to find out the tangent and the normal. Please remember, tangent and normal are 90 degree to each other. And when we have 90 degree, one is, if you take slope is as 1 m1, the other is m2, m1 into m2 will be negative 1. Okay, so let us start with the gradient of the function at certain point 3, 2. So dy by dx is what? Just differentiate it. It is 2x minus 5, 8 will be 0. So it will be dy by dx is 2x minus 5. So you have a point which is 3, x is 3. So just put 3 here. You don't have to worry about y here. So just put 2 into 3 minus 5. dy by dx at point 3 and 2 is simply slope, gradient of the function, or you can say slope m tan theta with respect to the positive x-axis. Now 2 into 3 minus 5 is simply 1. The slope of the tangent is 1. Now when you have the slope, when you have the point from which the line is passing, it is easier to find out the equation. We have y minus y1 equals mx minus x1. So this will be the equation of the tangent. So we have, this is a straight line formula. Please remember or recall, y minus y1 is equal to mx minus x1. x1 y1 is the point through which the tangent is passing, and m is the slope of the tangent, m we have found out as 1, y minus 2 equals 1 into x minus 3, 3 and 2 are the points. This is y equals x minus 1 is the equation of the tangent. Now in order to find out the normal, as I said, tangent or normal are perpendicular to each other. So the slope, which is nothing but the tan theta, so tan theta 1 into tan theta 2 will be equal to negative 1. You know already that. So m1 into m2, that is the slope of tangent and normal, is going to be negative 1. So once you have the slope of the tangent, which is 1, the slope of the normal will be negative 1. Okay. So minus 1 by 1 is negative 1. So now you know the point, because the normal is also passing through 3, 2. And you also have the tan theta, or you can say the slope of that normal, which is negative 1. So y minus 2 equals negative 1 into x minus 3. And this equation is going to be the equation of the normal. Now let me tell you how this normal is computed one more time. The normal is simply, we know that m1, m2 equals negative 1. So we already have the tangent, the slope of the tangent, gradient of the tangent. Now you can find out the slope of the normal. You can put it here. You have already the point. So y plus x minus 5 equals 0 is the equation. So this is all about differentiation. Thank you so much. Take care of yourself.